During this session, we'll continue our discussions on determination of, say, the EOQ with price discount. So already we have explained this concept in the last lecture session. Now, what we have mentioned that in order to determine this economic order quantity with price discount, the two approaches you may opt for. The first one is analytical approach and the second one is the graphical methods. So in this particular lecture session, we'll be referring to both the methods or both the approaches, and we'll take up a few important numerical examples. So this will be our coverage during this lecture session. Now, continuing our discussion on say the EOQ determination with price discount. So now we have explained the phenomenon, and we have mentioned that there are two types of the situations you come across. The first one is single price break, and the second one is the multiple price break. So let us first consider the single price break situation, and we'll take up analytical approach, we'll take up the graphical methods, and when you understand this analytical approach as well as the graphical methods with respect to the single price break situation, you will come to know, you will have a very good understanding of the concepts. Okay, the later on obviously the same concepts you can apply for some multiple price break situations. So while so the modeling this particular problem, we need to use several kinds of we need to consider several kinds of variables, the parameters, and we are trying to explain the rationale behind such modeling at each step. So let Q0 is equals to EOQ, economic order quantity without discount. Okay, so that is the first derivations we have, the original EOQ formula. Sometimes this is referred to as the classical EOQ formula, and the price discount count starts at Q equals to K into Q0, right? So what we are trying to do, that means the Q0 or the optimal order quantity or EOQ stands as the base, and the other quantities that we need to consider are expressed in terms of the EOQ quantity. Okay, so EOQ. So that's why we say that the price discount starts at an ordering quantity Q, and this Q you must explain in terms of Q0. So obviously there is a multiplying factor, that is small k. So the Q equals to small k into Q0. Discount rate is D, and hence if initial unit price is CU, the unit price with discount will be 1 minus D into CU. That means suppose the discount rate is 10%. It means what? That means suppose 10% discount and original unit price is 100 rupees. That means unit price with discount will be, so the 0.9 into 100, that means 90 rupees. Is it okay? So 1 minus D into CU. This is the general notation we have used. If the total cost with discount is less than that without discount, okay, without discount, we opt for discount, otherwise we forgo discount. That means what you try to do, when you accept discount, first you calculate what is this total cost, and supposing the discount is not offered, so what is the total cost, and then you check whether the total cost with discount is less than that without discount, then you opt for discount, otherwise you do not opt for discount or you forego discount. So this is the basic logic we establish. So hence now if you have say if you discount, okay, with the discount offered at a discount rate of D, so what will be the total the purchase cost? So the S is actually your yearly demand, and the purchase price is 1 minus D into CU with discount. So this is your purchase cost. Next, what is your ordering cost? So ordering cost per order is CO. Capital S is your your yearly demand, and how much you're ordering, that is K into Q0. That is your the ordering quantity with discount. So S by K into QO is the number of orders. For each order you are incurring a cost of CO. So this is the total ordering cost with discount. And now what is the average inventory you hold? That is K into QO by 2. Why 2? Because we are assuming that the demand is uniform, and the corresponding price is so the average inventory, this is in physical units, corresponding price is 1 minus D into CU, that is the discount price, and the inventory carrying cost will be I proportion of that. This is the average inventory which you hold. Now this total cost with discount must be less than this one. That means when you do not opt for discount. So this is S into CU plus S by QO into CO plus I into QO by 2 into CU. Is it okay? So if now this inequality expression you simplify, you manipulate, and with this substitution we use a term called capital M. Capital M is root over twice SCU by ICO. So the equality condition holds. That means the expression has got similarity with the original EOQ expressions, but please note down the difference between this expression for M and the EOQ expression. Is it okay? So it is M, if M is root over twice as CU by ICO, the equality condition holds when K, when that is the unknown. So I need to determine the value of K. So the expression for K is 2 plus dm plus root over 2 plus dm whole square minus 4 into 1 minus d divided by 2 into 1 minus d. Actually you will be getting a quadratic equation, and one root of this quadratic equation will be this one. So quadratic equation in terms of K, small k, and the K is the unknown. So this expression you get. So if less than K into Q0 units get the discount, order the least amount necessary to get it. Is it okay? So that is your decision. So first you determine the value of K. If the amount which must be ordered to obtain the discount is, follow this the logic, follow this logic. If the amount which must be ordered to obtain the discount is greater than K into Q0, discount should not be taken and Q0 unit should be ordered only. That means original EOQ. You forego discount. Okay. Determination of the order quantity can be explained with the graphical method also. So this is we have just proposed a simple analytical approach to decide if the discount can be accepted or discount cannot be accepted. Okay. So this logic you just follow. Now if you opt for a graphical method, possibly you will understand fully that what is the basic logic. Your logic will be made very, very clear. So let us assume that the CU1 is the first price without discount. We are just discussing the single price break situation, and the CU2 is the second price with discount. So obviously CU2 is less than CU1, right? Now we use QO, that is EOQ with CU1, right, and QO2 is equals to EOQ with CU2. Is it okay? So these notations we have used. Now 4 possible cases may be graphically illustrated, right, and for each of the cases, what you need to determine, you need to determine or you need to decide whether you will accept discount or not. If you accept, what will be your the order quantity? That's it. So what is case 1? Case 1 is just you have the total cost curve. So the total cost curve with CU1, CU1 is without discount. Whereas if you opt for so discount with the unit price CU2, then the total cost curve is this. Is it okay? So the vertical axis represents the total cost and the horizontal axis represents the quantity. Now what you try to do, suppose you are here, so you move like this, and at this point K into QO, is it okay? You have QO over here, that is the EOQ with CU2, but before you reach QO, you are getting a discount offer with CU2. So immediately you move to the curve or the total cost curve with CU2, and then you proceed in this direction. Is it okay? And so now the question is, and when you move in this direction, you come across a point on the cost curve, okay, which is the minimum, for which the order quantity, that is the economic order quantity with CU2, that is QO2. Now the question is whether you will accept discount or not. So as total cost against Q02, that means this one, okay. So now right now you are here, you will be moving along this line. This is the real one, this is the feasible alternative. So you reach over here. So obviously the total cost against QO2 is less than the total cost against KQ0. So KQ0, the total cost is this. Whereas if you traverse on this path, you get a order quantity Q02, which is the minimum. So and Q02 is feasible. Decision is accept discount and order quantity is Q02. It's clear? Next one is the case 2. Now you are moving on this line without discount, CU1. You reach here and you the cross QO also over here, QO is the minimum line. Now you reach over here and you are offered a discount at K into QO. Is it okay? So here obviously the value of K is greater than 1. In the previous case the value of K was less than 1. So here it is greater than 1. Now from here you reach this second card, and the second card represents the price discount with the price of CU2. Now what will be your decision? That means you can path like this, and as the total cost against KQ0 is more than the total cost against Q02, again the Q02 is a feasible, okay, you can reach Q02. The decision is accept discount and order quantity is Q02. So that is the second case. Now you can come across case 3 also. That means now you are moving along, this is the first curve with CU1 without discount. Now when you cross Q02 over here, okay, then the second curve, now at this point you are offered a discount. So you move to the second curve representing the total cost with discount, and the discount the price is CU2, unit price is CU2. So you reach over here. So here as the total cost against KQO is less than total cost against QO, and Q02 is not feasible because you cannot go back. That's why there this portion of the curve is shown as dotted. So the decision is accept discount, but the order quantity is just cannot be Q02, it is K into QO, because against K into QO the total cost is this, but against Q02 the total cost is higher. So that's why you accept the discount, but the order quantity is K into Q0. Now comes the fourth case. So the case 4, what do you find? So you move along this line, and at this level KQ0, okay, you are offered the discount. Is it okay? So as total cost against KQ0 is more than the total cost against Q0 and Q02, Q0 and Q02 is not feasible. Okay, so you cannot get this Q02 over here. This is on a dotted line. Decision is do not accept discount and order quantity is Q0, because Q0 is already you have traversed. So this is feasible. So Q0 is feasible. So here the case 4, don't accept discount, order quantity is Q0. So these are the 4 cases you come across. For all units discount, quantity discounts with multiple price breaks, the following procedure is to be followed to determine the minimum total cost order quantity for the given item. So when the multiple price breaks are offered, we have already explained what is this multiple price break situation. Now the certain steps you have to follow. The step 1, starting with the lowest unit price, calculate the EOQ at each unit price until a valid EOQ is obtained. That is step 1. Step 2, calculate the total cost for the valid EOQ and for all other price break quantities greater than the valid EOQ. A price break quantity is the lowest quantity for which the price discount is available. Okay, so we will take up one example. It will be made very clear. And in the step 3, in the last step, what do? Select the quantity with the lowest total cost as the order quantity for the given item. So you just follow these 3 steps and you will know how to calculate or how to determine the order quantity in a multiple price break situation. So what we have done, that the entire procedure we present with a flow diagram. So what is this flow diagram? You start, calculate EOQ with the lowest unit price. Is it okay? So you just find out lowest unit price and then you find out EOQ. Okay, is EOQ valid? That means when you determine EOQ with this price, now against this price the order quantity is mentioned. Now whether this EOQ falls in that range or not. If it falls in that range, it is called the valid EOQ. If it doesn't fall in that range, it is referred to as invalid. So supposing EOQ is valid, select EOQ as the order quantity. If it is not, then calculate EOQ with the next higher unit price. Suppose the lowest unit price is rupees 10, okay, and the next higher unit price may be rupees 11. So you calculate again EOQ with rupees 11. EOQ valid? The same question you ask. If it is no, then you go to the next one. Next one could be 12. Next one could be 13. So this process continues till you get a EOQ quantity or EOQ which considered valid. So if it is yes, now what do? Calculate total cost for valid EOQ and all larger price break quantities. Is it okay? So maybe beyond EOQ, the valid EOQ, you may have the 3 or 4 larger say the price break quantities. Is it okay? That is the minimum quantity against a particular price. Is it okay? Offered. So that is basically called the price break quantities. So suppose the 3 more price break quantities you have. So altogether you have 4 say the quantities. So against each quantity, okay, specified, you determine the total cost and select the order quantity with the lowest total cost. That's it. And just you remember that the total cost includes the total purchase cost also. So this is a numerical example. So so you just go through these numerical examples okay, and you will have all the data, and all the assumptions of the basic EOQ model are applicable. That we are assuming there are 10 assumptions. Now just to make a note that EOQ model is widely applicable, even if there are say the 10 assumptions. The question is why. Obviously you will find that the majority of the organizations, there are hundreds and thousands of organizations, they have been using EOQ model, original EOQ model, classical EOQ model, knowing fully well there are 10 assumptions. So obviously someone might say that if you have 10 assumptions, obviously you are in an ideal situation, but still many companies, they have been using EOQ model, original EOQ model, and they are getting positive results, and that's why they are accepting it. Now the question is why? Even if there are 10 assumptions, why do you use the EOQ model and what benefit? So this point we'll be discussing later on. This is one of the key questions the raised in any discussions on inventory management. Okay, so this is the quantities, the numerical example. The quantity ordered is this is your multiple price break situation. So if the quantity ordered is between 0 to, or maybe it's a 1 to 1999, it should be 1. Okay, 1 to 1999, it is 65. Between 2000 to 4999, it is 60. Like this, and you have this table with all the data, and over 10,000, it is just 50. What is the optimal order quantity? What is the minimum inventory cost? So assuming 300 working days in the year, so you have this annual demand, that is D. A is also known, ordering cost, and small I is 0.15, 15%, small I. So first we obtain EOQ using the most favorable unit price, that is the lowest price, that is 50. So it is Q star 490. Now it is feasible because the price of rupees 50 is available on an order of at least 10,000 units. So it's okay. So next we consider the price of rupees 55. So again you determine Q star 467 units. This being also infeasible, we consider the price of rupees 60. So this is infeasible actually. 490 with rupees 50 you can't get. Is it okay? So rupees 50. So rupees 50 over 10,000 only. So obviously you can't get. So this is infeasible. This is also infeasible. And the next one is next we try with 60. This is also not feasible. Thus we shall have to compute the EOQ value, consider the highest price of rupees 65. So when you consider the highest price 65, the EOQ becomes 430 units. So this is of course feasible. So you just refer to the table. Now we shall determine the total inventory cost at the feasible EOQ of 430 and at the various price break quantities, as we have already pointed out. So total cost at 430 comes down to this one, and like this the next price break quantity is 2000, next one is the 5000. You calculate the total cost for 2000, for 5000, for 10,000. These are the so the higher the price break quantities. So these are the values, and so the cost calculation shows that the total cost would be the minimum when an order of 10,000 items is placed. Of course the value of 10,000 is taken only for convenience, thus the optimal order size is 10,001 units. Okay, so follow the steps. This is the second examples the related to say the EOQ and reorder level. So here also what you have, that means you have to find EOQ and the operating days per year of the company, that the data are given, that there is 250 days. The procurement time is 10 days and the safety stock is 500 units. So you need to determine the reorder level, maximum, minimum and average inventory. So you have all these data. So please follow the steps. All the data are given. So you can use the EOQ expression Q star. Is it okay? that is the 5000 units, and then so annual demand 50,000 units, number of working days 250 days, average daily demand that you calculate. The lead time is 10 days, and the average demand during lead time. Obviously, it is the demand is uniform. The demand is known with certainty. So the average demand during lead time is 200 into 10, that is 20,000 units. So with the safety stock equal to 500 units, so we have the reorder level, that is the safety stock plus average demand during lead time. So that is 500 plus 200, that is 2500 units. So what is the maximum inventory? Maximum inventory is safety stock plus EOQ. So 500 plus 5000, 5000 and 500 units. So minimum inventory is the safety stock, that is 500 units, and the average inventory is safety stock plus half of EOQ, that means Q by 2, that means 500 plus 5000 divided by 2, that is 3000. Okay, so this is your EOQ is 5000, so this is 3000 units is your average inventory. Now so let us discuss the third example, numerical example. Let me read it out. The annual demand for a product is 3600 units with an average of 12 units per day. The lead time is 10 days. The ordering cost per order is ₹20, and the annual carrying cost is 25% of the value of the inventory. It's considered to be very, very high, 25%. The price of the product per unit is ₹3. What will be the EOQ? Find the purchase cycle time. Find the total inventory cost per year. If a safety stock of 100 units is considered necessary, what will be the reorder level and the total annual cost of inventory, which will be relevant to inventory decisions. Now here just you make a note that you have one parameter called ROP or ROL. Now this ROP, that means reorder point or reorder level, consists of two parts. The first part is the average the demand during lead time, and the second part is the safety stock. Now usually the safety stock when you have a probabilistic the demand, then only you need to determine the safety stock, and because of the fluctuations of demand during lead time as well as the fluctuations of the lead time itself, so you need some extra stock, buffer stock, we have already explained. So so here in this case, as the problem is under certainty, that means demand is known with certainty, then obviously the safety stock determination is not at all a problem. So what we have, so we have all these values, so the corresponding values we have. So EOQ you can determine √2 AD by H, so 438 unit. Purchasing cycle time, that is Q star per demand per day, is it okay? That is 438 by 12, that is 36.5 working days. It is just make a just you check that how it is calculated and all. Total inventory cost per year, is it okay? So this is 3600 into 3 plus 438 into 20 plus 438 by 2 into 0.75, that is this one, and the reorder level is the safety stock plus lead time demand. This point already we have elaborated, that is 100 plus 12 into 10, that is 220 units. So the total cost relevant to inventory decisions, the holding cost, average inventory into holding cost. So the average inventory you can calculate, the total holding cost also you can calculate, total ordering cost also you can calculate. Is it okay? That means the total number of orders into the ordering cost per order. Is it okay? And the total cost just you add, so you can also calculate 239 total holding cost and total ordering cost. If you add them, you get the total cost. So this is so these are the text references. So you go through, and what we have actually explained, what we have described, what we have the dealt with is that what are the EOQ models and available under different conditions, like original EOQ model, the EPQ model, EOQ with the shortages, and EOQ with the discounts. Now all these problems you frequently come across, and the typical, you should be also aware of the typical numerical problems. So we have cited a few representative numerical problems. So please go through them, and I am sure that with this the basic the knowledge in inventory, the dynamic inventory problem under certainty. So till now, now we have assumed that there is no constraints. In the next lecture sessions, what we will do, we will try to determine that order quantity or optimal order quantity. Always this is referred to as the economic order quantity or economic production quantity under constraints. Is it okay? That's so the treatment will be slightly different. We will discuss the problem formulation and how to determine the relevant how to get an expressions, or how to derive the expressions for the optimal order quantity under constraints. Okay, so more or less we have covered all the important aspects related to dynamic inventory problem under certainty. Thank you.